Hello guys, today we are going to be continuing our DBMS basic intro part 2, and the first thing which we are going to be talking about is terminology and concept, which and tables, relations. The very central concepts of relational databases are tables, relationships. Tables, which are formally called relation, is the building block of relational database. It stores data in 2D with its rows reflects one instance of record tuple, and each of its columns reflect one aspect of other attributes of all instances. Columns may also be called fields. For example, a student table may contain student ID and stuff, etc., and each row may represent one student information, and each column of the table represents one piece of information of all students. Moving forward, we are going to be looking forward to primary key and foreign key. Primary key is a unique identifier made of one or more columns to uniquely identify rows in a table. If the primary key contains more than one column, it can be called composite key as well. Foreign key is the primary key of another table which is referenced in the current table. Is the key to establish the relationship between the two tables and through DBMS to impose referential integrity. Now, moving forward, we are going to be looking at surrogate key. Surrogate key is a unique column added to a relation to use as the primary key when lack of a natural column serves as primary key, or when the composite key needs to be replaced for various reasons. Surrogate key is usually in form of auto-increment numerical values and of no meaning to the user, and thus CD often hidden in the table or form or other entity for internal use. Surrogate keys are often used in the place of composite keys to add more flexibility to the table. And in the second point, we say a relation. Don't get confused. A relation just means a table. Now, moving forward, we're going to see terminology and concept. ER model. ER model means entity relationship data model. Is the common technique used in database design. It captures the relationship between database tables and represents them in a graphical way. The relationships between two entities can be 1:1, 1:n, or m:1. 1:1 means one object to one object. 1:n means one object to many objects, or m:(n) means many objects to many objects, and it is usually established through foreign key constant. Examples are 1:1 employee locker, 1:n customer order detail, m:(n) student, and course, because course is a multiple. There can be a lot of courses for one student, there can be a lot of courses for a lot of students, means different. So moving forward, we are going to be looking forward to the examples of ER model. In our screen we can see some examples of ER models, and you may know that in the ER model, means database model, ellipse is used for an attribute, and entity set is represented as a rectangle, and a relation is represented as diamond. And one more concept we are going to study, which is normalization. Wikipedia definition says that database normalization, or simply normalization, is the process of restructuring a relational database in accordance with a series of so-called normal forms in order to reduce data redundancy and improve data integrity. It was first proposed by Edja F.Code as an integral part of his relational model. Normalization entails organizing the columns and tables of a database to ensure that their dependencies are properly enforced by database integrity constraints. Now let's see the unnormalized form, which says same attributes can be contained in one row. If you want to see the examples, just pause the video time by time. I'm going to be talking about a lot of these. Now, moving on, we are going to see the first normalized form, which says each attribute can only have one single value in one row, no duplicated row, and no row column order. Means there will be no order for row and column. Second normal form. Second normal form says first normal form plus no partial dependency. Non-key attributes may not depend on any of the candidate keys. Second normal form continued, which says the same thing, but it's just the example which they have continued and showing us the complete part of it. Now let's see the third normal form, which is second normal form plus transitive dependency. Non-key attributes may not depend on each other. Now moving forward, this third normal form continue means the graphs are continued, the examples are continued. Moving forward, we are going to be seeing the Boyce Codd normal form BCNF, which says third normal form plus non-dependency between all the candidate keys. And here Boyce Codd normal form says the same thing, just it is an example for it. Now they are going to be showing us more examples on the screen. You can see there are a lot of examples. If you want to see them, you can pause the video.